3.1 seemed nice and easy. I feel like we have a nice momentum going. Let's keep going with 3.2, if statements and control flow. We're going to start off with the notional machine. On the left-hand side, you have some code. Take a minute and read through that code to see if you can figure out what is going on. Our code starts off, we are importing the scanner class from the java.util package. On line 2, we have our class definition. On line 3, we have our public static void main, which is our entryway into our program. On line 4, we are declaring and instantiating a scanner named in. We are assigning it the reference returned from calling the scanner constructor after passing in the parameter of a reference to the system.in. In our stack memory, we are going to have a variable named in. It is going to be a reference that says that we have a scanner in heap memory. Line 6 will print to the console the string, how many horns do you have? Line 7 will pause and wait for some user input. In our example, the user has entered in the number 1. Line 7 declares the variable horns, which gets created in stack memory, and it gets assigned the int literal 1. On line 9, we see a new programming structure. We see the keyword if, and inside parentheses, we have horns equal to 1. We should recognize what is happening inside the parentheses there. We have a relational operator in there. We have our equal or our equal to operator or our comparison operator. That's creating a Boolean expression. That Boolean expression is going to evaluate to either true or false. In memory, we see that horns is 1. We are asking if horns is equal to 1. That will evaluate to true. We will step inside that block of code and we will print something to the console. We're going to print, dude, are you a unicorn? We will still continue. We will do line 11, line 12, and at line 13, we have another if statement with another Boolean expression inside parentheses. Again, we are using the equality operator. We are asking if horns is equal to 2. Horns in memory is still 1. We're asking if 1 is equal to 2. That's going to evaluate to false. We are going to skip that block of code because that Boolean expression evaluated out to false. We will not execute that algorithm. We'll skip to the closing curly on line 15. On line 17, another if statement, horns equal 3. 1 equal 3 evaluates out to false. We're going to skip that algorithm that is attached to that if statement. On line 21, we're asking if horns is greater than 3. 1 greater than 3 evaluates out to false. We are going to skip that algorithm as well. Here we have the same block of code. We are still creating our scanner that goes into stack memory. Now on line 6, when we ask how many horns do you have, we will pause on line 7. We will get the next int from the console. We see that the user typed a 4 in the console now. When horn is declared and initialized, it will be assigned the value of 4 this time. When we get to that if statement on line 9 and we ask if horns is equal to 1, in memory horns is 4, we're asking if 4 is equal to 1, that's false. We will skip that block of code. On line 13, we're asking if 4 is equal to 2, that is false. Skip that block of code. Line 17, we're asking if horns is equal to 3. 4 equal to 3 is false. Skip that block of code. Down to line 21 now, we're asking if horns is greater than 3. 4 greater than 3. That will evaluate to true. We will get to go inside that algorithm and execute all of the lines inside that algorithm. And then we will print, dude, are you a tank? So what we see in these examples is that we are not going to necessarily execute every single line of code that we write anymore. This leads us into our next topic, which is control flow. Our learning objective, represent branching logical processes by using conditional statements. Now, when I was a wee child, I used to read these books that were called Choose Your Own Adventure books. You would read the book and something exciting would happen, and you would have a decision that you would need to make. And based on what decision you make, you would turn to a different page in the book, and then you would have a different outcome. So you wouldn't read the story straight through. You would read the story to a certain part and jump to a different page and make a decision, and you might jump back pages and forward pages, but you would jump all around based on the decisions that you made, and you would read some pages, but you wouldn't read all of the pages. So, looking at how our programs have executed in the past, we have written sequential statements. That means that each code statement was executed one after another, top to bottom. They would all be executed in their turn. We can see the example of that where we are declaring an integer variable to hold a width, an integer variable to hold a height, an integer variable to hold the area, which is the calculated width times height, and then we print out the area. Those four steps happen in order. You couldn't do step 4 first because there is no area declared, and it was not calculated because there was no width or height calculated. You have to do step 1, then 2, then 3, then 4. What we are going to move to is control flow or conditional statements. That's going to allow us to do some branching logic. We can stop and ask a question, and based on how that statement evaluates, we can do a different step or just skip and continue with the other step. We are still flowing downward where everything will come back together at some point, but we will branch off and do different things for a while before we come back and join back up as one. This aligns with our essential knowledge. Conditional statements interrupt the sequential execution of statements. Once we start using these conditional statements, we're not going to have that sequential step-by-step execution anymore. Let's take a look at some flowcharts using some more realistic examples. Starting at the top of the flowchart, we are declaring a total and assigning it the value of 12.5. So this might be for a grocery store program. We calculated the total of all of our items, and then we want to stop for a second and ask a question. We want to know if we have a coupon, because if we have a coupon, we're going to get some money off. If we don't have a coupon, then we're just going to keep going. So if we do have a coupon, we take that branch to the left and we subtract $1.50 from what we owe, and then we continue with everybody else that didn't have a coupon, and then we see our total. Another example of that could be like a cookie clicker program where every time you click, you get 2 cookies. So we start off, we just clicked, so our cookies went up by 2, and maybe you get a bonus if you have over 100 cookies. So we ask if cookies is over 100. If you do, you get that 1 cookie bonus. If not, you just continue, and then the people that do get that cookie bonus will join up, and then we will print out the number of cookies. This aligns with our essential knowledge. If statements affect the flow of control by executing different statements based on the value of a Boolean expression. We see inside both of those diamonds, we have a Boolean expression. Has coupon sounds like a Boolean variable that will evaluate to true or false. Cookies greater than 100 has one of those relational operators in there, creating a Boolean expression, which will evaluate to true or false. This is going to lead us into our next topic, the if statement. Looking at that same learning objective, represent branching logical processes by using conditional statements. As we mentioned, sometimes the computer is going to need to ask a question of us, and depending on if we get that question wrong, the computer can do one thing, or if we get that question right, the computer can do a different thing. That's going to be our new statement, the if statement. Our description, a conditional statement that if true, performs an algorithm. We see an example in the box on the bottom, It starts off with that keyword if. That is just one of those keywords that Java knows. It's one of those reserved words. Immediately following the keyword if, inside parentheses, we have a Boolean expression. One way to know if you have a Boolean expression is if you see one of those 6 relational operators inside of it. Greater than or equal to, less than or equal to, or not equal to. Not every Boolean expression needs a relational operator, but if you see a relational operator, that's a dead giveaway that you have a Boolean expression. After the Boolean expression, you have an algorithm contained inside of curly's. We have that block of code. Now that algorithm will only execute if the Boolean expression evaluates out to true. And that algorithm doesn't need to be just one line of code. It could be 2 lines of code. It could be 100 lines of code. This aligns with our essential knowledge. A one-way selection or if statement is written when there is a set of statements to execute under a certain condition. In this case, the body is executed only when the Boolean condition is true. Looking at our flowchart example from earlier of the portion of a receipt program, we can now see that in code on the right. Our first blue box is step 1, where we are declaring and initializing a double variable named total and assigning it the double value of 12.5. On line 2, we are also declaring and initializing has coupon. We are setting it equal to false. And then on line 3, that's where that diamond comes in, the if statement. We are saying if has coupon equal to true, then we see that block of code. We can only get in there if we are telling the truth, if that Boolean expression evaluates to true. If that is the case, we will subtract $1.50 from the total. And either way, whether we got in that if statement or if we didn't get in that if statement, we will always execute line 6 and then print out that total. In this particular example for line 3, when we get to line 3, has coupon will evaluate to a false. Our Boolean expression is then asking if false is equal to true. That whole Boolean expression will evaluate out to false. When we go to print, we did not change total on line 4. We skip over that algorithm and go right to line 6. And at that point, total is still 12.5. That's what would be displayed in the console. Looking at a very similar block of code, the only thing that we are changing is line 2, where we are initializing that Boolean variable to true. In this case, when we get to line 3, we have our if statement, we have our Boolean expression inside that if statement. Has coupon at this point will evaluate to true. We are asking if true is equal to true. That whole Boolean expression will evaluate to true, which means then we step inside and we do all of the lines of code inside that algorithm. In which case, we will subtract $1.50 from total. Total will become 10.0. As we continue to execute code, when we print out, we will print out the value of 10.0, and that is what we will see in our console. Very similar lines of code with slightly different outcomes if the Boolean expression evaluates to true or if the Boolean expression evaluates out to false. That's going to bring us to the end of this lesson. Make sure that you rate how you feel on that learning objective. Read your recap statements. Hit me up with any questions or concerns that you have regarding this content. Join us in our next video and keep programming.